Okay, let's take a look at tutorial 3 question 1. Suppose that the expected rate of return on the market is 20%. Okay, so let's just highlight this. The return on the market is 20%. And the risk-free rate is 8%. Okay, I put a hat on it, but really it's just a constant. It's not a variable. That's just my habit. Further, assume that the standard deviation of the market is 32%. So the standard deviation on the market portfolio is 32%. Assume the market portfolio is efficient. So part A, write down the equation of the capital market line and draw its graph, label the axes, just label everything up, very nice essentially. Okay, so firstly let's deal with this word efficient. What does that mean? Well, it means you cannot increase returns for some fixed level of risk. Okay, so you fix some risk and you have the maximum possible return. You cannot get any more. And we know from the theory that the capital market line, so the maximum return for a given level of risk, follows Sharpe's ratio, which says the risk premium on the market portfolio relative to the risk-free portfolio per unit of risk. This is the market risk. This is maximized by Sharpe's portfolio, Sharpe's constant. Okay, so we drop these in. The market rate we know is 20. The risk-free is 8. So we get in 12 on the 12 premium on the risk-free rate. Standard deviation is 32%. So Sharpe's ratio is 0.375. This is the gradient of the capital market line. So the capital market line is the expected return on some complete portfolio which contains some risky assets and a risk-free asset. 0.375 times the standard deviation. This is like y equals mx, and then the constant, the c, is the risk-free rate. Okay, so there you go. This is the capital market line. It's always done this way. Calculate Sharpe's ratio, that's the gradient, and the y-intercept, the c, is the risk-free rate. Okay, so we need to plot this. So a simple plot. Capital market line looks at the risk on the x-axis and the expected return on the y-axis. I think it'd be quite useful to put on the opportunity set here. So let's assume this is the opportunity set for some risky assets. So we got some individual assets in here, and we take a portfolio of them. We're looking to maximize the expected return on the portfolio. And the capital market line, the market portfolio, is tangential to this opportunity set. So if I just draw it on maybe here, tangential, okay, not so easy. There you go. That could be worse. Okay, so this is the capital market line. I won't draw over the top of it. Maybe this one. This is the capital market line, and this is the market portfolio. Maybe put this in a different color. It's quite important. This is the market portfolio, tangential to the opportunity set, sitting on the capital market line. Okay, not much more to say there. I suppose I could label these up. These are the risky assets, individual risky assets. I think that picture is clear enough. Okay, so that's part A. Part B, let's take a look. Let's remind ourselves. So if you desire an expected return of 40%, what risk should you take essentially? What should the standard deviation be? So 40% expected return, what is the standard deviation? Well, using the capital market line, a little bit of rearrangement. If we calculate risk in terms of some fixed desired return, simple rearrangement, it should follow this equation. Okay, so if we pick some value now, so we set our portfolio to have an expected return of 40. Well, this means that the risk associated with that, we can write these as decimals or as percentages, just don't mix them. And divide by Sharpe's ratio, we get very large standard deviation of about 85.33%. So a fair bit of risk associated with that, quite high expected return. Okay, part C. Part C, there's a few details, let's highlight them. Something different. What could we choose? Nothing too dark. Okay, a bit boring, let's go grey. So we invest 400 quid in the risk-free asset and 600 quid in the market portfolio. How much should you expect to have at the end of the year? Okay, let's try it. So we're investing £1,000. We have 400 in the risk-free asset, 600 in the risky assets. Okay, so straight away we can calculate these weights. So we have 0.4 invested in the risk-free, 0.6 in the market. So the expected return on this complete portfolio, standard calculation, it's the weighted average which equals, well, I'll just drop all the numbers in. 0.6. Oh yeah, just write the answer. Drop those numbers in, which is about 15.2%. How about the risk associated with that? Again, standard formula. I've got the habit of writing in this term, even though it's always zero. It just helps me remember the equations. The risk associated with the risk-free asset is by definition 0. So drop those numbers in, 0.192, pop that in the calculator. So the risk reward pair, well, the reward 15.2% and the risk 19.2%. And there you go. That is the end of the problem.